Okay, this is the fourth side of the notes packet from 6.4 on the dot product that we didn't have time to finish in class. This page deals with parallel vectors and how we can determine if vectors are parallel. So we can determine if two vectors are parallel in two ways. We know that two lines are parallel if they have the same slope. So I'm going to fill that in up here. If they have the same slope, the lines are parallel. In terms of vectors, two vectors are parallel if they have the same or opposite direction. Okay, so using this idea, we can say that vectors u and v are parallel when v equals ku. That means v is a scalar multiple of u for some real number k. This makes sense because v is a scalar multiple of u, meaning that it lies along a line with the same slope in either direction, but it has a different magnitude. If k is negative, we would have the vector u in this direction, and then we could take v equals ku. The vector u would get flipped in the opposite direction. That's if k is negative, or k less than 0. The easiest way to determine if two vectors are parallel is to determine if one vector is a scalar multiple of the other. And we're going to do that in the example for at the bottom of the page. But in terms of dot products, we can also use dot products to determine if two vectors are parallel. So let's go through this analysis. In the first diagram that we have here, we have u and v in opposite directions. In this case, the angle theta between the two vectors is 180 degrees. If we think back about the unit circle, cosine of 180 degrees, I'm going to draw a little unit circle here, corresponds with this point. This is 180 degrees on the unit circle. The coordinate of this point is negative 1, 0. Cosine, remember, is the x-coordinate of a point on the unit circle. So cosine of theta, in this case, cosine of 180 degrees is equal to negative 1. So our alternative definition of the dot product is u dot v is the magnitude of u times the magnitude of v times cosine of the angle in between them. When theta is 180, cosine of theta is equal to negative 1. So u dot v is equal to the opposite of the product of the magnitudes of u and v. Let's look at the second case. Here, u and v are in the same direction. That means the angle between the vectors is 0 degrees. Cosine of theta, or cosine of 0 in this case, we draw another unit circle, corresponds to this point on the unit circle, that's 0 degrees. Its coordinate is 1, 0. Remember, cosine is the x-coordinate, so cosine of 0 degrees is equal to 1. So that means cosine theta here is equal to 1. So u dot v is simply the magnitude of u times the magnitude of v. So if two vectors are parallel, if their dot product is plus or minus the product of their lengths. Okay, so when the vectors are in the same or opposite directions, the dot product is the product of their lengths. If they're the same direction, it's positive. If they're in opposite direction, it is a negative value. But to determine whether two vectors are parallel, it's going to be a lot easier to check this by using scalar multiplication. So example 4 says, determine whether the vectors u and v are parallel using scalar multiplication. Okay, so here we have the vector u, which is given as 2, 3, and v, which is given as 8, 12. So the vectors are going to be parallel if they're scalar multiples, and we can check this by checking if the ratio of the x components, so I'll write that out, the x components is equal to the ratio of the y components. Okay, so we're going to see, so vectors are parallel if the ratio of the x components is equal to the ratio of the y components. So let's set that up. The ratio of the x components for this set of vectors is 2 over 8. So this is the ratio of x components. Is that equal to the ratio of the y components? The ratio of the y components is going to be 3 over 12. So this is the ratio of the y components. So let's simplify both of these ratios. So 2 over 8 simplifies to 1 over 4, and 3 over 12 simplifies to 1 over 4. So we can say, yes, U is parallel